Have you ever really thought about the ground beneath your car? Or, like, the tarmac under a plane's wheels? It just seems so simple, right? Just this solid, silent thing that's always there. But what if I told you it has a secret life? A story written in layers and layers of stone and asphalt.
Seriously, what if that road you drive on every single day could actually talk? What if it could tell us, hey, I'm strong over here, but I'm starting to get a little weak on this side? Or what it needs to stay safe for you and millions of other travelers? I know, it sounds like something straight out of science fiction.
Well, guess what? It's not science fiction at all. It can talk, and using some really incredible technology, engineers are, well, they're listening to our infrastructure every single day. And in this explainer, we're going to break down exactly how they do it.
All right, so first things first. Before you can manage anything, I mean anything, you've got to know what you're working with. And when it comes to our infrastructure, that means creating a truly massive, super detailed inventory of every single piece of pavement out there. And when I say massive, I mean it. The scale is just immense. We classify absolutely everything. We're talking about the huge national highways that connect the country, all the way down to the little local street you live on. And you have to remember, each one of these serves a totally different purpose, so it needs to be managed in its own unique way.
And it's not just about roads either. This same super detailed logic applies to all kinds of complex networks. Think about our airports, the runways, the taxiways where the planes pull up, or our ports, right? With these huge areas for containers and all that heavy equipment moving around, it's all part of the network. Okay, so once we know what we have, the next big question is, what's it actually made of? See, back in the day, the only way to figure that out was to dig a big hole. Not ideal. But today we have something that's basically like X-ray vision for our roads.
I mean, just think about that old method for a second. Digging these trial pits. It was destructive, it was super slow, and yeah, it was really expensive. The new way is literally the exact opposite. It's fast, it's completely non-destructive, and it gives us this amazing comprehensive picture of everything happening under the surface.
And the tech that makes this all possible is called ground penetrating radar, or GPR for short. It's a pretty remarkable system, really. It lets us see all those hidden layers beneath the surface without ever having to dig a single hole.
So how does this magic actually work? It's actually pretty elegant. The GPR unit sends an energy wave down into the pavement. Now, as that wave hits different layers, the asphalt, the stone, the soil underneath, part of that wave reflects back. It's just like an echo. And by analyzing those echoes, engineers can create a perfect map of the road's internal structure. It's genius.
All right, so knowing what's inside the road is absolutely critical. But what's on the surface is just as important. We need super precise data on things like lane width, the slope for drainage, so water runs off, and even the curve of a turn. And to get all that, we use the power of light.
The technology here is called LiDAR. It stands for light detection and ranging. Basically, it shoots out millions of tiny laser pulses and then measures exactly how long they take to bounce back. The result? You get this incredibly detailed 3D map of, well, everything. We call it a point cloud, and it's amazing.
Now, what's cool about LiDAR is how versatile it is. You can use it at all different scales. So let's say you need maximum detail for a really specific area, like a complicated intersection or maybe a bridge. For that, engineers use something called terrestrial LiDAR. They just set it up on a tripod, and it performs this super high-res stationary scan.
Okay, but what if you need to map, say, hundreds of miles of highway? You can't use a tripod for that. So you take that same LiDAR sensor and you mount it on a vehicle. This is mobile LiDAR, and it's a game changer. It captures the entire road network while you're just driving along, creating this continuous 3D model. And finally, to get the biggest picture of all, LiDAR literally takes to the sky. When you mount it on a plane, this airborne LiDAR can map entire regions at once. This is how we get those massive digital elevation models that are just so crucial for things like long-term city planning or managing the environment.
So, let's recap. We know what our network is, we know what it's made of, and we know its exact 3D shape. The final critical piece of this puzzle is understanding how it's actually being used. And trust me, this is about way more than just counting cars. When it comes to collecting traffic data, the tech pretty much falls into two main camps. First, you've got your intrusive systems. These are sensors that are physically placed inside the pavement itself. They do things like weigh trucks as they drive over. But more and more, the world is moving toward non-intrusive systems, which are mounted above or just beside the road. And these modern sensors use a whole bunch of different technologies. We're talking infrared for heat detection, laser radar, microwave radar, even ultrasonic sensors. The amazing part is they can count cars, measure their speed, and even figure out if it's a car or a truck, all without ever physically touching the road.
Okay, so we've collected these 4 massive streams of data, right? We have the inventory, the construction details, the 3D geometry, and all the traffic info. So what happens next? This is the really important part. This is where all that information gets turned into action.
All of that raw data we just talked about, it all flows into this powerful software hub. It's called a Pavement Management System. And inside this system, these incredibly smart, predictive models analyze everything to forecast how the pavement is going to wear down over time. This is what lets engineers make smart, proactive decisions about when and where to invest millions of dollars in maintenance. It's how they fix things before they break.
So, when you boil it all down, here's the crucial point. Every single decision, from fixing one little pothole to rebuilding an entire highway, depends completely on the quality of the data. Bad data, that leads to wasted money and, frankly, unsafe roads. But good data is what keeps our entire world moving, safely and efficiently.
So you see, through this constant stream of data, our roads, our runways, our ports, they're all talking to us all the time. They're telling us exactly what they need. And that leaves us with just one big question. Are we investing enough to actually listen to what they have to say?